Okay, in this video we're going to have a look at electrolysis, and this is going to be an introduction to electrolysis. In order to understand electrolysis, we have to go back to a little bit of work we've done before, which is looking at ionic compounds. Okay, so just a little recap of the important bits of ionic compounds. So you should remember that ionic compounds exist in an ionic lattice. This means they have positive ions, negative ions, positive ions, negative ions to form this structure. Each of the lines in between are the electrostatic attractions, and these electrostatic attractions hold the lattice together, hold the ions in place, and this means that as a solid, ionic compounds will not conduct electricity because the ions are not free to move. So the question is, what can we do to allow ionic compound to conduct electricity? And what we can do in here is we can either dissolve it or heat it up and make it molten. And when we do that, this lattice starts to break apart. So the lattice starts to come apart. Therefore, the ions are free to move and it will now conduct electricity. And we need, in order to do electrolysis, we have to have ionic compounds in either a molten or in a dissolved state in a solution in order for electrolysis to happen. We're going to explain that part next. Okay, so to understand electrolysis, let's just look at what the word means to help us understand this. Electrolysis is we're going to use electricity, and the word lysis means to break down, to break apart. So we use electricity to break down these ionic compounds in this process. So ionic compounds are broken down. The chemistry word for that are decomposed, and they break down into simpler substances using, and this is very important, a DC, direct current electrical supply. So electrolysis is breaking down ionic compounds into simpler substances using a direct current power supply. What does that actually mean in simple terms? Well, here's an example. Here is sodium chloride, an ionic compound, and if this undergoes electrolysis, then what we can do is split this into the elements. So we form sodium and we form chlorine. Remember, chlorine is diatomic, so Cl2. These are the elements, and these are a simpler substance than the compound that we started with. So this is what electrolysis does. Remember, in order to do this, these ionic compounds that we're talking about have to be molten or dissolved, and the reason it has to be molten and dissolved is so the ions are free to move. And when we have that, we call it an electrolyte. So if we have a molten or dissolved ionic compound, we call it an electrolyte. And again, this helps us understand what the word means. Electro is to do with the charges, and light means loose. So the charges are loose. So electrolyte, loose charges, ions are free to move about. Okay, in this video, let's have a look at the basics of electrolysis then. So the setup, if you remember, we need to have a power supply that is going to be a direct current power supply, okay? And the power supply they're connected to two electrodes. So here I'm going to have, this is one of my electrodes, okay? And here is my other electrode. And these electrodes we're going to call the cathode and the anode. I'm going to come back to explain why in just a moment. The electrodes are often made from graphite, carbon. You should know why, because we need these to conduct electricity. Graphite is a non-metal, but it conducts electricity. And you should remember that that's because the carbon structure inside it forms 3 bonds per carbon atom. Therefore, it's got a spare electron that's delocalized and can conduct. Okay, so we have, just to recap, power supply, DC, wires connecting to two electrodes, and the electrodes sit inside this container, and this container contains my electrolyte. Okay, in this example here, my electrolyte, remember this means the ions are loose, is going to be sodium chloride, and I've made it molten, so the lattice is broken down and the ions are loose. And here it's going to be loads of ions in, but I'm going to use just a few to make it easy. In my example, here's my two of my ions examples that are now loose and able to move around. So when I flick the power on, these ions are going to be attracted to an electrode. Now, to help us understand which one they get attracted to, let's just have a look at this. This is the sodium ion, and it's positive. And a name in chemistry for a positive ion is called a cation. So the cation is a positive ion. Okay, so the cation is a positive ion. And the cations go to the cathode. That's why it's called the cat cathode. So they are going to migrate, that just means move, in that direction. So cations are attracted to the cathode. Great to remember that. If you had the youth go to the youth club. That's why it's called a youth club, because that's where the youth go to. Old age pensioners go to an old age pensioners club because that's where they go. So cations go to the cathode. Okay. Now think about what this means. If this is a positive ion and it's being attracted to the cathode must have a negative charge because opposites are going to attract each other. So the cathode is negative and it attracts the cations, which are positive. Okay. Opposite, the anode. Well, the anode is where the chloride ions are going to migrate. Again, just means move. So they're going to move towards the anode. Why do they do that? Well, chloride ions are anions. Okay. To help you to remember this, I always write the word anions with a capital N there to help me remember they are negative ions. Okay. So these are negative ions and they head towards the anode. Therefore, the anode, if it's going to attract negative ions, must be positively charged in order to attract those ions. Okay, so anions go to the anode, cations go to the cathode. If you want a way to remember the cations, cats and positive, I love them. Okay, so you've got cats and positive, I love them, and anions with the N in for negative ions, they go that way. So that's the basic setup. We're then going to have a look in a second, next part of the video, as to what happens to these ions once they've migrated to the electrodes. Okay, so in this video we're going to have a look at what happens to the ions once they've migrated to the electrode. And to help us understand this, we need to look at the word Aurovig. And Aurovig is related to oxidation and reduction because it's these two reactions that happen at the electrodes. Okay, and to help us remember what Aurovig stands for, here's what it is. Oxidation is loss and reduction is gaining. But I hear you saying gaining and losing what? Well, this is all about electrons. So oxidation is the loss of electrons, reduction is the gaining of electrons. And you think about it, you should remember that electrons are negative. So if I lose electrons, if I lose negative, what will I do? I will become more positive. And if I gain electrons, what am I going to do? I'm going to gain negative, therefore I'm going to become more negative. So to help us understand this, in your notes you've got one of these little number charts. And if I'm becoming more positive, what am I doing? I'm losing electrons. So this, in this direction, we are losing electrons, and if I lose electrons, what's going on here but a process of oxidation? I'm becoming more positive. If I gain electrons, then I'm going to become more negative. So this way here is all about gaining electrons, and therefore this process is reduction. Okay, so we've got two steps in this method that we need to understand, all about oxidation and reduction. So how does this relate to the example that we've been talking about using sodium chloride? Well, let's just remind ourselves, if we have sodium chloride, we have NaCl, and electrolysis of this is going to cause this to break down into simpler substances. So we're going to form sodium and we will form chlorine. Sodium is the cation, so sodium is Na+, and it goes to the cathode. Once it gets there, what happens here is the cathode is now going to try to get rid of the positive charge. So how do you get rid of a positive charge? You give it a negative charge. I'm going to give it electrons. So I'm going to add an electron and it forms sodium, Na. So here, my sodium ion is gaining electrons. If I'm gaining electrons, come back up to this, reduction is gaining. I am gaining electrons, therefore this is an example of reduction. And the product of this reaction, what's going to be produced, is sodium. Anode. Anode is where the anions go. So the anion in this ionic compound is a chloride ion. And what we've got to do here at the anode is we've got to get rid of the negative charge. We've got to get rid of this electron. This electron sitting here, got to get rid of it. So this will form chlorine and it will release the E minus. So this electron that makes it negative is now being released, being lost. Okay, you should remember that chlorine is diatomic, therefore I need Cl2. If I need 2 chlorines here, I need 2 chloride ions, and if I'm going to have 2 chloride ions, I will release 2 electrons. My chloride ion is losing electrons, therefore this process is oxidation. Okay, so in this process we have got a process of reduction at the cathode. At the anode we've got oxidation. These two always happen together, and to help us to recognize that, we often call these redox reactions because you have reduction and oxidation happening at the same time. Okay, again, please stop the video, go through it, watch it again, make sure you've got the basics, because this we're going to start to build on, and we really need to make sure that we've got the basics of electrolysis. Okay, now we've done the introduction to electrolysis, it's worth just applying the work you've been doing to a situation here. Okay, so what you've got here is a list of electrolytes. All of them are molten, and then I want you to identify what reaction is going to happen at the cathode, which reaction is going to happen at the cathode, and which reaction will happen at the anode. Just a reminder of this, the cathode is where the cations go, and cations are positive. Remember, cations, I'm positive, I love them. So this is the negative electrode, and therefore the anode is where the anions go, the negative ions go, therefore this is the positive electrode. Okay, so here's my electrolyte, lithium chloride. This contains lithium ions, which are Li+, and chloride ions, which are Cl-. If you're struggling to understand why this is the case, just remember, very quick sketch here, that in the periodic table, there's my periodic table, group 1 form positive 1 ions, then you've got positive 2, positive 3, 0, and then it goes -3, -2, -1, and 0. So because lithium is in group 1, it forms a +1 ion. Chlorine forms chloride ions, which are in group 7, which is a -1 ion. So that's how we know the charges on these. Okay, so the lithium ion goes, being the cation, goes to the cathode. When it gets here, how do we get rid of this positive charge? We're going to add an electron, we're going to give it an electron, it's going to gain an electron to form lithium metal. Because this is gaining electrons, this is an example of a reduction reaction. At the anode, my chloride ions, my anions, we're going to go there, so my anion goes there, which is a chloride ion. That is going to form, it's going to lose the electron to form chlorine, and there's the electron that's being released. Chlorine, remember, goes around as 2s, it's diatomic, therefore I need 2 lots of this, and it's going to release 2 electrons. This electron is being lost. Loss of electrons using Ohrig is oxidation. Okay, what I want you to do, there are now some other ones here for you to have a go at. You should now be able to construct each of these equations showing you the reaction at the cathode, reaction at the anode, and what I will do is put this as an answer sheet at the end, and you can then check your answers to make sure that you have them correctly done. There's some tricky ones in here, watch out. Oxygen's a particularly tricky one. Just check and make sure you know exactly what is going on in those. Okay.